Hi folks, welcome back to the shop. This is Iron Horse Machinery. My name is Greg. Today I'm getting back on the work on making these little brackets for my antique Ford Smith tool and cutter grinder. So in the last video we roughed out some pieces, we made a design, roughed out some pieces of aluminum, and they're over here on the bench. And so today we're going to lay out and then machine the next features on those parts. So hope you enjoy. Hey everyone, so we're over at the mill. I've got these parts clamped back up and put in the vise. Remember the last time I took them out, I had them all clamped together in the vise, milled both sides. A smarter person than me would have left them clamped together, but I wanted to show them on the bench, so it was easy enough to put them back into the vise, clamp them back together again. Vise is cranked up nice. I've tapped them all down onto a couple of small parallels who are in there, and they're nice and tight, so everything is secure. I have my radius cutter in here, or quarter round cutter, and so now I'm ready to put that rounded over edge or rounded over corner detail that was in my drawing. So I'll start this up and show a few minutes, or not even a few minutes, a few seconds of that, and then when I have both sides milled I'll come back and we'll lay out the next parts. Thanks. Okay, I've done one side. You can see that came out pretty well, just a little bit of handwork to smooth up the transitions. I flipped the parts over, so now we have the next edge to do. I'll just show a little bit of that. So we'll turn the machine on. I crank this by hand so you'll see a little bit of that. Alright, that's the second side done. I'll take them out, we'll go over to the bench, and I'll show you what the next layout step is. Alright, we're back to bench. Here's one of those parts. I've got all of them over here with the radius on each side. This is our drawing here. So I have a through hole here that's tapped 3/8 through hole. That's where the little set screw goes through. We have a slot here which is 3/8 of an inch wide, and it's a 1/2 inch up from the bottom. So I'll lay those out first. I'm going to do it on my little surface plate. I have a bigger surface plate in the other room. I have a little bit more of a metrology setup there, but for layout we're going to use this. This is way overkill for a simple part like this, but you know, I always find it kind of fun to do things accurately. So I'm going to take my gauge block set. So this bottom one is 1/2 inch. The center of the hole is 1/2 inch up, so I'll get a 1/2 inch gauge block, which I should have right here. So here's my 1/2 inch gauge block. I'll put that under here. Lower our, and we'll just tighten that up, and we can get Just down to where we need it. Turn it the wrong way. There we are, just starting to drag on there now. I guess would be a good idea. Alright, so now I can scribe a line across there. So that's my 1/2 inch line up from the bottom. The other part, the hole that goes in here is 3/8 of an inch down from the top, so we don't have a 3/8 gauge block, so we'll have now I have a stack of 0.375, so I can get down to that. There we go, just starting to touch. I can mark this. Alrighty, then I can mark the center. This is 2 inches, so I just need 1 inch. Move this up. There's a 1 inch gauge block. Spider web on there. Just starting to touch there. So that'll be my center. And then for this one, we had a 1 inch hole, and it's a 2 inch part, so that means 1/2 inch in from each side. So we'll just take the 1/2 inch gauge block. Oops. There we go. Just tickle that a little bit, 1/2 inch, flip it over, 1/2 inch. So that's our layout for this side. Let's just have a look at our drawing. So we need 3/8 hole, 3/8 of an inch down from the top. We have the center of that marked. We have this slot, which is 3/8 of an inch wide. 1/2 inch up from the bottom and 1/2 inch in from each side. So we have that marked out. Now we can flip it over and mark out for the that feature on the back, which is basically a large groove. Well, I flipped the part over now. This is the back side, and what I need, according to the drawing, is a line at 1 1/8 inches. Now I could do that with my gauge blocks and my little height gauge, but of course that's not something you need to do. You can do it much easier, at least for this class of work. You wouldn't even need to do the layout. You could put it in the machine and edge find and move over with your end mill. That's the normal way to do it. I just like to lay things out ahead of time just to prevent bozo mistakes, because if I know where the line is, I can still do the layout or the positioning on the milling machine, but at least I have a reference that I can look at and make sure that I haven't screwed up by, you know, not advancing the table by 1 full crank or something silly like that. So what I've done in this case, rather than going through that, I've set my caliper at 1 1/8 inches, so 1.125, and we can just scribe along here with the caliper like that and make a mark. And that's plenty good enough for a visual reference when I'm setting up on the machine. And I'll go ahead and do the same thing on the side here. I've been using this Starrett layout die. It takes a while to dry, which is a bit of a pain. So the other thing you can do is just use a Sharpie. Sharpie works fine for this. And just make some marks on there with the Sharpie. That dries almost instantly. And the depth of that shelf that we're cutting on there is, well, I don't have the depth, it's 3/4 of an inch, so what I'm leaving is 1/4 of an inch, so I can set 1/4 of an inch on my calipers here. So there's 0.2, oops, let's go, there's 2, 0.25, there we go, 0.25, oops, down. Let me just recheck that to make sure I haven't made a bozo mistake. So there we are, dial, lock the dial, about 250. There. Mark that here. Oh, didn't quite get with my blue, but I'm just catching the edge of it. Okay, so that gives me, I'm going to just redo that a little bit because I didn't go quite down far enough. So there's our mark. So that gives me a visual reference. When I'm setting up my milling machine, I can find the edge of my, I'll do an edge find, move the mill over to where the cutting tool is right at this edge. I can double check that it's there, and I can set my depth and double check that I'm hitting that line approximately. Now, all right, we're over here at the mill. I got my piece that's marked. I have my other pieces. So what I'm going to do is put it in the vise and line up. What I have in here is a pointer. I have a bunch of these of all different sizes, and that's handy when you're drilling to have one that's the same size as the drill you're going to be using, in this case a 3/8 drill, because then you don't have to move the chuck very much to swap between the pointer and the drill. And it's especially handy if you're using a collet and trying to line up where an end mill will go, to have a pointer that's exactly the same, the size of the collet, and obviously the same size as your end mill, so you can line up the starting position for that. So I have a whole bunch of these. This is just a couple of them. I make them out of drill rod in the lathe, put a point on different sizes of drill rod, or in this case a piece of tooling of some kind. Alright, so I'm going to put the piece in the lathe, or in the milling vise, and in order to be able to reproduce exactly the same positioning on all the other parts, since they're all milled exactly the same size, I've got a couple parallels in here, and I'm just using a rule and pushing the part up to the edge of the rule like that. So now it's aligned with the vise edge. I'll just tap it down to make sure it's seated firmly on the parallels. There we go. And now I can pick up the center of that hole, just moving the table. Get down close here. Now you could center punch those intersections if you wanted to, but for something like this, I can line it up very accurately with the sharp point that's on that little pointer. Alright, so we'll take that out, put in our drill bit. I'm using a stubby bit. I like to use these when I can, because, first of all, because my mill doesn't have very much of a work envelope, and secondly, the shorter the bit, the stiffer it is, and it's less likely to wander around. And so this way I don't need to spot drill it or anything. I can just shoot straight in there. So we'll start the first hole, and then we can line all the rest of them the same way. Open the vise, take the part out, put the next one in, line it up with the rule, and rinse and repeat. All right, so I always like to use a little bit of cutting fluid. It helps keep chips from building up in the drill. Also, I didn't mention this is a 3/8 16 threaded hole, so the tap size for that is a 5/16 bit. All right, so now I can take this one out. Get the next piece, set it in here. Now I don't have to lay out anything on those next pieces. Line it up with the edge of the vise. Tap it in place, and away we go. Alright, so now I've got my 3/8 16 tap with a tap handle. I've got a tap follower in there with a spring point, so I can load that up and make sure that the tap is going in straight. And again, because I have positioned all the parts to drill them exactly the same, I can go back and do the tapping and be certain that I'm lined up exactly over the hole. Now if I had a mill with a DRO, that would be an easy way to do it, but I don't, and this way is also accurate, certainly accurate enough for the kind of work that I'm doing here. Alright, so let me just run that tap all the way down. Take that out of the way now. So now I've flipped the parts, so not really flipped them, but rotated them 90 degrees so I can set them in the vise this way. Remember, my next cut is that slot that goes across here. It doesn't have to be all the way through because I'm milling away a big piece of the backside here, so it's only, what's going to remain is only a 1/4 inch deep. So I only have to mill just over a 1/4 inch deep slot in there. By rotating the part this way, I can do my move in the x-axis of the table here, and the reason that's convenient is I have stops on each side and a piece in the middle that does that. So I can use my same trick with the pointer. I've already got it lined up, so there's my center of the right hand side of the part. So I can move this little stop. So that's where the stop will hit. Just adjust that a little bit. Things are a little fiddly because, of course, this is not really a precision machine. Reset. All right, we should be ready to make some chips. So just bringing in here, this is another one that we just did. You can see in this case I didn't need to have any layout lines or anything because I'm able to put the part back into the vise exactly the way the first one was, use my stops, use my depth mark, and then I can just run through them all the same way. That noise is kind of horrible, kind of screeching sound. I'm sure I could dial in the speed a little better if necessary, but just for 4 parts, I'm not going to worry about it. Great, so this is the last milling operation here, milling this big step out of here. Turn the parts so that so the cutting forces are towards the back jaw of the vise, the fixed jaw of the vise. That's always good practice. I've got a 1/2 inch roughing end mill in here. I just did a little test cut and it seems to be pretty happy. I'm doing full depth of cut and about, well, not quite a 1/4 of an inch step over, maybe a little more like 3/16. We'll see if I can increase that a little bit. These roughing end mills are really good on a small, low-powered machine like this. They cut a little bit more smoothly because the teeth kind of lead to a more steady tool pressure. They don't tend to vibrate as much, and I just find that they give me really good results on a small mill like this. So I'll turn the mill on, I'll show you how that's going, and then I'll just do the rest off camera because it's going to be kind of boring. So that's working well. I'll step over and continue to cut full depth. When I get to the end, I'll probably switch out and use a regular end mill just to do that finishing cut, because this of course leaves a little bit of a serrated finish on the side mill portion. It does a nice job on the bottom. It leaves a nice flat finish. Also note that I've put wider parallels in here to get the part up high enough so that I have clearance to do this 3/4 inch deep cut here and leave a 1/4 inch of material at the bottom. Because I can't really get the tool pressure fully against the back, there's a lot of tool pressure in the along part direction, in the X direction here. And because I've got relatively little grip surface because of the tall parallels, I brought out the big crank so that I can really put some force on the jaw to make sure that it's held firmly in place. If I was worried, I could put a block here to make a stop. You'll also notice I've centered the part in the vise. You don't really want the part to be off one side or the other, because then the vise jaws will cock just slightly and you'll only really be getting full grip on one corner. Whereas if you get it in the center, then the vise tends to stay square and will push evenly against the whole part. Alright, so I'll go ahead and do the rest of these off camera. Alright, well here's our parts all finished. I took them to the little belt sander, little Kalamazoo 1x42 belt sander, and just touched up all the edges and corners, and I put them on the 3M buffing wheel and made them a little softer, polished them up a little bit, and finished tapping those holes. So yeah, they're all done now. These parts are done. You can see they look just about like the drawing. And where they go, I'll just walk across here. So on my old grinder, these sit in here. There's a bolt hole that will hold them in so that they can be moved back and forth. And then just like over on this side, where I have my little temporary one, they'll sit in here, and there'll be a screw that goes in there with a dog point on it that engages with a little countersunk hole in the corner of the table. So that's it for that. When I get the other table back, I will go ahead and install all of these pieces, make the little screws that go in there, and that will be the end of it. All right, well, that's the end of this little project video. I hope you enjoyed that. I'm pretty happy. The parts came out well. One of the things that you might notice on some of these parts is that the hole is, where I made the slot, there's a slight enlargement on the ends here, and that comes back to what I talked about in a previous video about all machines being elastic. So that milling machine is not very stiff, and when it's cutting, the cutting forces are pushing the cutter off slightly, so it's cutting along here, and then when you stop cutting, it takes the sideward pressure off the cutting mill, the end mill rather, and then where it dwells, it pushes over or rebounds just slightly and leaves that little extra amount, which maybe you can see right there. So that's kind of unavoidable. Even on a big mill, you get a little bit of that. If you really couldn't live with it, you'd have to use a smaller end mill, an undersized end mill, and then go down one side and back the other side, and then you can make a nice clean slot. I mentioned that the table for the other side of my little tool and cutter grinder is broken. I sent that off to my son, Jeff. He has a machine shop and a YouTube channel called Kuroki Machine Shop. It's a proper industrial kind of machine shop. He's got big machines. His big manual lathe would not even really fit in my shop here, which is just a single car garage. Lots of cool old machines that he has, as well as new machines. He does all kinds of interesting work, a lot of it on hydraulics, so repairing and rebuilding hydraulic cylinders and pumps and hydraulic motors, does small production runs of custom hydraulic cylinders, and then does lots of just general job shop repair machining, the kind of thing that's kind of dying out a bit, but there's still a real demand for it, and he's built up a really successful business doing that. He also does repairs on cast iron, which is a kind of specialty skill, and he's started a series on his channel about how to properly repair cast iron, particularly with brazing, which this little table part, which broke completely, he's got that there, and he's going to use that as a demonstration for how to repair a broken casting like that using brazing, which is really the only proper way to do it. I mean, there are other methods, and maybe for something like a table like this that isn't really loaded very heavily, it's just supporting a cutter as you're grinding it. Maybe there's other methods that could work and could stick it together, but they're not really reliable, and the proper way is with brazing. And so he's going to demonstrate that. And when I get that part back from him, when it's all finished, I will do a final little video where I put it back on my tool and cutter grinder, and then maybe demonstrate the use of that machine for you. So I hope that was enjoyable. I had fun. I'm glad I got those parts made, and looking forward to getting this machine back into service. Thanks very much for watching. See you next time.